Welcome to the discussion on the topic finding the centroid of composite section. Under this, we are discussing now rectangular component with circular hole in it. What is the given problem? Find the centroid of the component as shown in figure. Here, for this rectangular component with circular hole, we have to find the centroid. The breadth of the rectangle is 100 mm and the height of the rectangle is 160 mm. And radius of the circular hole is 10 mm and the circular hole is at a distance 120 mm from the base and 80 mm from the left side of the height. Next step is drawing x and y axis for this component. Draw x and y axis for the component. X axis and y axis. Regular rectangular component with a circular hole in it is given. So what we have to do is, from regular rectangular component, circular hole is to be subtracted to get the centroid of the given component. Next step is recollecting the formula on centroid of rectangle and circle. Rectangle, B is the breadth, H is the height, then centroid of the rectangle is B by 2 and H by 2. Here it's a circle. O is the center, R is the radius, D is the diameter of the circle. So the center of the circle is R comma R, that is small r comma small r. Then we'll move towards finding the centroid of a regular rectangle given in the problem. It's a rectangle. Breadth is 100 mm, height is 160 mm. So we have to calculate the centroid of this rectangle. X-axis, y-axis, and this is the location of the centroid point. Centroid point is at a distance x1 from y-axis and y1 from the x-axis. x1 is equal to 100 by 2 and y1 is equal to 160 by 2. x1 is equal to 100 by 2, that is 50, and y1 is equal to 160. This is y1. y1 is equal to 160 by 2. y1 is equal to 160 by 2. Then area of this rectangle is 100 into 160. Area of rectangle section is 100 into 160, which is equal to 16,000 millimeters square. X1 is equal to 50 mm and y1 is equal to 80 mm. Next we'll move towards finding the centroid of a circular hole. It's a given component. This circular hole is to be removed from the rectangular section. Then we'll find the centroid of this circular hole. X-axis, y-axis, and circular hole. Circular hole center is at a distance. Circular hole center is at a distance 120 mm from the x-axis and 120 mm from the x-axis and 80 mm from the y-axis. That is, the circular hole center is at a distance 80 mm from the y-axis, 120 mm from the x-axis. So x2 value is 80 mm, y2 value is 120 mm. Again I am saying the centroid of this circle is at a distance 80 mm from the y-axis and 120 mm from the x-axis. So x2 is equal to 80 and y2 is equal to 120. Then area of the circle is pi r square. R value 10 mm. Area of the circle is equal to pi r square, pi into 10 square, which is equal to 314 millimeters square. X2 is equal to 80 mm and y2 is equal to 120 mm. Now we will calculate the centroid of the overall component. the given values are placed in a table, then xc is equal to a1 x1 minus a2 x2 by a1 minus a2. We have to substitute a1 value, x1 value, x2 value and a2 value in this equation. Then after substituting those values, we will get xc is equal to 49.3 mm. Then yc, y coordinate value is equal to a1 y1 minus a2 y2 by a1 minus a2. a1 value, a2 value is given here and y1 value and y2 value also given here. Just substitute those values in this equation. Then yc is equal to 79.2 mm. So the coordinates of the component are xc is equal to 49.3 and yc is equal to 79.2 mm. Those values are shown in the figure. xc 49.3 and yc 79.2 mm. So therefore the centroid of the component is 49.3 mm and 79.2 mm. Like that we will calculate the centroid for the composite sections. I hope everyone understood well. Thank you.